Hello class, and welcome to the final day of section 9.3, which is going to be about radical equations. By the end of today's lesson, you will be able to solve equations that have radicals in them. When you are doing this process, you are going to be following normal SAD-MEP procedures. The only difference is you are going to do everything outside of the radical, so solve SAD-MEP for everything outside of the radical, and then you are going to solve SAD-MEP for everything inside the radical. So start with the outside and then work your way inside. So, for example, we've got 1.34 times the square root of h is equal to 9. So first job, we are looking outside of the radical, and outside of the radical, we've got 1.34. 1.34 is being multiplied with that radical, so we're going to go ahead and divide both sides by 1.34. When I do that division, I'm going to get the square root of h is equal to, when I divide, I'm going to get a long decimal, but with rounding, that's going to give me 6.72. Now, everything outside of that radical is gone. When the radical is isolated, so everything on the outside is gone, you are going to go ahead and square both sides. Squaring is the opposite of the radical, so that eliminates the radical, and we end up with just h is equal to 6.27 squared, which is going to give me 45.11. So again, everything outside of the radical gets solved. Once everything on the outside is gone, you're going to square to get rid of the radical, leaving whatever was on the inside. And then in this case, it was just h, so I was done. If there had been anything else other than the variable on the inside of the radical, you would have to continue with SAD-MEP to solve for the variable. Go ahead and try this one on your own. Notice there's nothing outside our radical, so we're going to start by just squaring both sides. When we do that, we keep the 2n from the inside of the radical. 65 squared was 4,225. Cutting that in half, we get 2,112.5 as our value for n. Looking at this next one, again, we're going to start with anything outside the radical. In this case, we have a minus 2. So I'm going to go ahead and add 2 to both sides of the equation. Now I've got the square root of c minus 3 is going to equal 11. Nothing is outside of the radical, so I'm going to go ahead and square to get rid of that. So when I square both sides, inside the radical stays as c minus 3, and that is equal to 11 squared, which is 121. In order to finish solving, I'm going to need to get rid of that minus 3. So I'm going to add 3 to both sides, giving me a final answer of c is equal to 124. Go ahead and try this one on your own. Start by subtracting 7 from both sides, squaring to get rid of the radical, and then subtracting 5. You get an answer of a is equal to 20. So this so far has happened when we have it equal to a number. Now what happens when we have it equal to a variable? So we've got the square root of c minus 1 is equal to c minus 3. Nothing outside of our radical, so I'm going to go ahead and square. We need to square this whole value. So again, square root and square cancel out, so I've got c minus 1 is equal to, when we're squaring, again, that goes back to that special case that we learned in chapter 7. So we can either write it out as c minus 3 times c minus 3 and use FOIL, or we can remember our shortcut, which is square the front, so c squared, multiply c times negative 3, which is negative 3c, double that to get negative 6c, and then square negative 3, which is going to give us positive 9. So if you have a variable and a number on the other side, you're going to have to square that using that special case. Now, we need to continue solving, so I need to get this set equal to 0. This is a new thing that we have not yet talked about when we are solving quadratics, which is what we're going to get focused on in the second part of this chapter 9, but this is just going to be a brief introduction to that. In order to keep solving here, we need to get it set equal to 0. So I need to subtract c and add 1. So that's going to make the c go away and the 1 go away. So the c is going to be subtracted with the c's, and the adding 1 is with the other numbers. So now I have that 0 is equal to c squared minus 7c plus 10. This is going to go back into now chapter 8. We need to figure out what multiplies to 10 that can add to negative 7. So off to the side, I'm going to make a little list, and I have 1 times 10 and 2 times 5, but I need to get to negative 7, so I'm going to make it a negative 2 and a negative 5. So I can make that as 0 is equal to c minus 2 and c minus 5. Now, because this is equal to 0, that means either this front piece needs to equal 0, so c minus 2 would equal 0, or the back piece would equal 0. c minus 5 is going to equal 0. In order to solve the first part, you're going to add 2 to both sides. So when you add 2, you would find out that your first possible answer is going to be 2. And when you add 5, you find out that your second possible answer is going to be 5. So we end up with 2 answers for this problem because there was a variable on the other side. Go ahead and try this one on your own. Squaring both sides, we're going to end up with x squared plus 6x plus 9 equals x plus 5. Move those two values over to the other side to get it equal to 0. The things that multiply to 4 that add up to 5 from your options of 1 and 4 and 2 and 2, you pick out 1 and 4. And then when you solve, you end up with negative 4 and negative 1. If you have questions about this or anything else from the lesson, please let me know when you get to class.